Hello everyone, this is Randolph Parker. Today I'm looking at the circuit diagram for the PS9KX power supply, the Pyramid power supply. In earlier videos that I posted, I have mentioned that I took a standalone 12-volt rechargeable battery with some jumper cables with the input for a cigarette lighter and plugged it in here. What I needed it to do was to take the output of this voltage from these posts and recharge my battery. By doing what I done, created a component explosion. So I was taking the time to identify on the schematic where the components were on the board. So with the schematic, I basically just had to trace out the output diode, which is here. This is the output diode. And upon visual inspection, you realize the burnt capacitors, right? I realized this capacitor is burnt out. So I started there. So I wanted to find where this capacitor was on the schematic, which is C7, 100 microfarad, is where that capacitor is on the schematic. So also I noticed during my visual inspection is that this resistor is burned out. I don't know if you can see it or not, but that resistor is burned out. So I wanted to identify where that resistor was on the board, which is R13 100 ohms. So basically, I just trace this point to this point to get a continuity check. The meter buzzed off, letting me know, hey, this junction and this junction and this junction are the same. So what I did with my marker, I just highlighted the components that I suspect that are bad, that I'm going to replace, blindly replace. From my experience working on car audio amps, when my clients would come in with the car amp blown, you had transistors and MOSFETs that were blown because what they would do is bridge the output of the audio amp to get more power, right? So by bridging that, you just basically parallel the output. You're going from 4 ohms to 2 ohms. And then, but the problem with that concept is that the load box, or the load, being the speakers in this case, still is at 4 ohms, and what you do is create a mismatch of impedance and of power transfer. So any power surge or whatever the case may be, when these young guys do that, is going to go back into the car amp. It was easy fix, easy repairs. And what we do in that case, we just change out those components in line with each other, and that will be the transistors and the MOSFETs, because transistors and MOSFETs work together to give you your high current and high voltage to give you power out, right? So what is that? P equals I times E. So that in that case, so I'm taking that concept and implying it here, right? I'm just going to basically just do a blind component replacement, and then when I feel that I replace enough components without really digging into, and it's a method that you do to save time. I don't recommend it. You can still do your pro check, but if you do a visual inspection, one thing about a technician tool, one of the tools are the eyes, right? This is a smaller bore, and I go, hey, I can visually see. I know what I've done. I saw the power supply smoking, so it's not like I should be surprised when I open it up. But when you open it up, you just want to see how much damage was done to the board, right? So upon my visual inspection, I go, okay, I did some damage here, right? I have this capacitor bad. Why not change out this? I have these diodes and capacitors in stock, so why not change out that? The two larger capacitors in the input of the transformer, I see some damage around it. Not major. Maybe I would save that for later just to see. So the input fairly look okay, but the output section looks bad. When I took the voltage here, when everything was still assembled together, I got 4.5 volts out. So I'm like, okay, my output is bad. So everything off the output seems like, not every component, but I should change, especially some of the active components, the semiconductors like the transistors, the Zener diode. I don't know. You probe, you check. You may have shorts. You may have open where you think you should have a short. You have an open. You have an open. When you get the concept. So to try to avoid that, you do the blindly replace components that you can visually see that's burnt out. And in some cases, it helps the troubleshooting process go quicker. In some cases, you might have a dead short somewhere, and you change all the components out, and bam, those components are bad. But for the most part, like I say, with the car amps, the car audio amps, it was like, for us in our shop at the time, it was like heaven. But at some point, you tell your customers, listen, what you're doing, you're adding, you're bridging the output of the your car audio amp, creating a mismatch in impedance, or some you see some stuff like where they add in all these capacitors to store energy, and in a car cause, I don't work on cars, but you have the double alternators and all that stuff causing major electrical problems to cars. And just to, this is during the late 90s and early 2000s, where up in New Jersey, New York areas, having a great sound system in your car was like to die for back in those days, right? You see the younger kids, the younger generations going back that way with a great sound system, but the newer cars have great sound systems already, and you shouldn't have to, you don't need to upgrade, but it's coming back. It's coming back in a big way. But we used to fix stuff. I had a guy who was the bridge between the installation world of audio amps and the bench world, because I wouldn't go out there and troubleshoot the stuff in the car. They would bring the amps to us to see if we could save the amps and stuff like that. And we, for the most part, we did, right? So you charge a customer $100 for a repair. You change it out. You put the amp. You have a head unit on your bench. You plug it up, and you burn it in for a couple of hours, or maybe 24 hours with a load. Make sure everything is working, nothing popping, and no oversaturation, no clipping. But 3 months later, they come back with the same problem. And now you gotta honor their warranty due to the fact that they telling you, hey, then you gotta let them know what's going on. Like, listen, you can't do this, blah blah. If you're gonna do that, you have to change your low speakers to match your output impedance with your low impedance, and that will hopefully reduce the mismatch of impedance and causing you're blowing out your MOSFETs and your transistors in the circuit. But this is where I am right now, Saturday. So I'm going to basically just start. First I'm going to, being that the transformer wires is already marked and labeled, I'm going to use my label maker just to say, okay, for example, this one is number 8. So with the label maker, I can just tag this as yellow wire 8, yellow wire 7, yellow wire red, and I don't need to use any markers on the board, because again, the PCB has the markers already, numbers of the wire. I just got to identify, if this is red 1 and this is red 2. And so when I disassemble this board, I can easily put it back together and make sure everything is working correctly. But yeah, that resistor is burnt out. This cap is burnt out. Here's the pot. This cap really seems good, but these two, for whatever reason, I don't know why. I don't know. Maybe they're not bad. It's just something got melted in there. I don't know. Yeah. So yeah, this is Randolph Parker MS. It's always great to get yourself a schematic. I remember I was working on a Rockford car amp in early 2000s, 2004, and a client. Yeah, I couldn't. Some schematics and diagrams were not as available as they are today, and I had to. I had to send the car amp to Denver. I didn't make too much money on that particular car amp because Rockford, if I'm pronouncing it correctly, Forsgate, I think that was called Rockford Forsgate. They didn't. It was hard to get their documentations, so they was like, "Well, just send it in." So I just got like a broker fee for the repairs because I couldn't charge my customer like try to make a whole lot of money off this. If I'm charging $100 and Rockford Forsgate, if I'm pronouncing it right, if they charge $100, there's no way I can make any money, right? So the most I can make was probably $25 just to send it. And in most cases you lose money. But now, I mean, this is not this is a pyramid power supply bench for your bench, and I was just basically schematics everywhere. A pictorial, the components would have been better along with the schematic because I could just say, oh, but tracing it through with a smaller board like this is not hard or difficult to do. But imagine you had a 2-3 layer board with over 100 to 1,000 components, and you're trying to just basically use a schematic to try to trace yourself through to see. It could be a little difficult. And guys who can do it, hats off to them. But I don't like to troubleshoot without a schematic. I don't like to probe blindly. Although I will replace components blindly, but I'm replacing the components that I can actually see on the schematics. So I just gotta know where they are. So in most cases, having a schematic along with a like a pictorial components is also a great tool to help and aid with the troubleshooting. So that's all I have for today. Again, this is Randolph Parker MS. Thank you for checking out my channel. If you'd like to subscribe, please do. If you'd like to leave a comment, please do. If you'd like to hit the like button, please do. I'm just doing this for fun and to also enforce what I have done for over 30 years. And I come to my shop, in my lab, in my house, just to fine tune my skills. This helps me at 52 years old to still retain some of the information and knowledge that I may have lost throughout my career and as an engineering tech and as a technician and things like that. So this does help me stay sharp. So again, this is Randolph Parker MS signing off. Guys, have a great day.